So, you want to learn Python for data science? Awesome. But let's be real, it can feel like you're staring up at this giant mountain of information with no idea where to start. Well, today we're handing you the map. I mean, does this look familiar? Just staring at this massive ecosystem of tools and libraries and thinking, where on earth do I even begin? Yeah, it's a super common feeling, and honestly, it's for a pretty good reason. Because here's the secret. The real challenge isn't learning Python itself. The syntax is actually pretty friendly. The hard part is navigating the huge ecosystem that's built around it. It's all about knowing what to focus on right now and what you can safely ignore until later. So, how do we tackle a mountain like that? Simple. You don't try to climb it all at once. We're going to build your skills layer by layer, starting with the most critical part, a rock-solid foundation in core Python. This is where the journey really begins. I'm serious. Before you even think about downloading a cool data science library, you absolutely have to get a handle on the programming fundamentals. This isn't just a suggestion, it is the bedrock everything else is built on. It might not be the flashiest part of the journey, but trust me, it is completely non-negotiable. Let's break that foundation down into what I like to call the 4 pillars. First, you've got variables. Think of them as little boxes for storing information. Then you have statements, which are just the specific actions you want your program to take. To repeat those actions without typing them a million times, you use loops. And finally, to keep all your code neat, organized, and reusable, you bundle it into functions. You get these 4 down, and you're absolutely ready for the next level. Okay, once that foundation is solid, it's time to assemble your core data toolkit. These are the libraries you're going to be using pretty much every single day. They are the true workhorses of data science. And first up is pandas. You can think of pandas as your universal translator for data. Got data in a spreadsheet, a CSV file? Pandas is how you bring it into Python so you can actually start to make sense of it. It is the starting point for, probably 99% of data projects. And this quote just nails it. It's been called the library that turns raw files into something you can actually work with. See, it's not about doing fancy analysis just yet. It's about that crucial first step of loading your data, cleaning it up, and shaping it into something usable. Now, working right alongside pandas, a lot of the time behind the scenes is NumPy. If pandas is kind of like the body of a car holding everything together, NumPy is the high-performance engine making it all go incredibly fast. It's the whole reason Python can crunch millions of numbers in the blink of an eye. Okay, so you've loaded your data, you've cleaned it up, but what does it actually say? Well, that's where Seaborn comes in. It's a visualization library, and it is designed for one thing: getting insights fast. And here's the magic of it. With just one single line of code, you can create a powerful chart that helps you spot trends, find relationships, and see outliers. It's amazing. But what if you need more control? What if you need that chart to look exactly how you want it? That's where Matplotlib comes in. If Seaborn is like a fantastic auto setting on a camera, Matplotlib is full manual mode. It gives you total power to customize every single label, color, and title. It's perfect for when you need a polished, presentation-ready visual. All right, with your core toolkit in hand, you are ready to add some power tools to your belt. These are the libraries for the more specialized stuff, like building predictive models and doing those really deep statistical dives. And this is where data science really starts to feel like data science, right? Scikit-learn is the undisputed king of introductory machine learning. It gives you this simple, consistent way to build models that can do things like predict a house price, classify an email as spam, or find natural groups among your customers. But what if you're less of a fortune teller and more of a detective? You don't just want to know what might happen. You really need to understand why. And that is the job of stats models. It's all about traditional statistical modeling, explaining relationships, and, this is so crucial, measuring your confidence in those findings. So here's the crucial difference. Scikit-learn is totally obsessed with prediction. Its only question is, can my model accurately forecast something for new data it's never seen before? Stats models, on the other hand, is all about inference and explanation. It asks, is the relationship I'm seeing actually real and statistically significant, or could it just be random chance? You see? They're both vital, but they answer fundamentally different questions. And finally, let's talk about where data actually lives in the real world. Because most of the time, it's not in some neat little CSV file on your desktop. It's stored in a massive database somewhere. SQLchemy is the essential bridge that lets your Python code speak the language of databases, so you can pull exactly the data you need reliably and safely. Okay, so now you know the tools. Let's talk about how to actually learn them. Because knowing what to do is one thing, but knowing what not to do, that's just as critical for your success. Let's just walk through these common traps real quick. Number 1, trying to learn everything at once. Don't do it. Your goal is to get really good with your core toolkit, not to kind of know 20 different libraries. 2, don't just memorize function names. Focus on the workflow. Understand the story of getting from a raw file to an insight. 3, embrace messy, real-world data. Don't avoid it. That is where the real learning happens. 4, I know it's tempting, but resist the siren song of machine learning until your data cleaning skills are solid. And finally, number 5, please do not ignore SQL. It's how you're going to get your data in almost any professional job.
You know, it all really boils down to this one idea. Real progress, it comes from going deep with a few essential tools to solve actual problems. It does not come from collecting a long list of libraries you barely know how to use. Focus on the problem, not just the tool.
And there you have it. That's our roadmap. It's a clear path through what can feel like a really confusing landscape. It's structured, it's focused, and it absolutely works. So the only question left is the one right here. You have the map. What are you going to build?